Welcome to our lesson on colloids from NIOS Class 12 Chemistry. In this video, we'll explore what colloids are, their properties, and how they differ from other types of mixtures. So, what exactly are colloids? Colloids are heterogeneous mixtures where tiny particles of one substance are dispersed throughout another substance. These dispersed particles are larger than those in true solutions, but smaller than those in suspensions. Specifically, the size of colloidal particles ranges from 1 nanometer to 1,000 nanometers or 1 micrometer. Colloids are classified based on the physical states of the dispersed phase and the dispersion medium. The dispersed phase is the substance that is scattered throughout, while the dispersion medium is the substance in which the dispersed phase is distributed. Let's look at the 8 types of colloids. 1. Sol, a solid dispersed in a liquid like mud in water. 2. Emulsion, a liquid dispersed in another liquid, such as milk where fat droplets are dispersed in water. 3. Foam, a gas dispersed in a liquid or solid, like whipped cream or sponge. 4. Aerosol, a liquid or solid dispersed in a gas, such as fog or smoke. 5. Gel, a liquid dispersed in a solid, like jelly or silica gel. 6. Solid foam, a gas dispersed in a solid, like styrofoam. 7. Solid sol, a solid dispersed in another solid, such as colored gemstones. 8. Solid emulsion, a liquid dispersed in a solid, like butter. Now, let's discuss the important properties of colloids that make them so unique. 1. The Tyndall effect. When light passes through a colloidal solution, it gets scattered by the colloidal particles. This scattering of light makes the path of light visible. This effect is named after John Tyndall and can be observed when sunlight passes through a forest. You can see beams of light due to this scattering. 2. Brownian movement. Colloidal particles exhibit random zigzag movement. This occurs because the particles are constantly being bombarded by the molecules of the dispersion medium from all directions. You can observe this under an ultramicroscope. 3. Electrophoresis. Colloidal particles carry an electric charge, either positive or negative, under the influence of an electric field. These charged particles move toward the oppositely charged electrode. This property is used to purify colloidal solutions. 4. Coagulation. This is the process where colloidal particles come together to form larger particles, causing the colloidal properties to disappear. Coagulation can be triggered by adding an electrolyte mixing with an oppositely charged colloid, or by heating or cooling. Let's now talk about some important applications of colloids in our daily life. 1. Purification of drinking water. Alum is added to muddy water. The positive aluminum ions neutralize the negative charges on colloidal clay particles, causing them to coagulate and settle down, making the water clear. 2. Food industry. Many of our food items are colloidal in nature. For example, milk is an emulsion of fat and water, ice cream is a foam, and jellies are a type of gel. 3. Medicines. Many medicines are colloidal in nature for better absorption in the body. For example, colloidal silver was used as an antibiotic before the development of modern antibiotics. 4. Industrial applications. Colloids are important in the production of daily use items like inks, paints, rubber, and paper. Let's summarize what we've learned about colloids. 1. Colloids are heterogeneous mixtures with particle sizes ranging from 1 to 1,000 nanometers. 2. They are classified into 8 types based on the physical states of the dispersed phase and dispersion medium. 3. Key properties include the Tyndall effect, Brownian movement, electrophoresis, and coagulation. 4. Colloids have numerous applications in water purification, food industry, medicine, and industrial processes. Remember that colloids are all around us in our daily lives, from the food we eat to the products we use. Understanding their properties helps us appreciate how these substances function and how we can use them effectively.